3 nights ago, the Deep Space Network logged a pattern that shouldn't exist. Equal intervals, repeating tones, a rhythm that persisted across 3 observatories. At first, it looked like interference, until someone noticed the intervals matched a perfect Fibonacci sequence. The detection occurred at 2:34 Universal Time on a Tuesday morning when most of the world was asleep. The Goldstone Deep Space Communications Complex in California's Mojave Desert had been conducting routine tracking operations, monitoring faint radio emissions from the outer solar system. The antenna, a 70-meter dish capable of detecting signals from spacecraft billions of kilometers away, was sweeping through its assigned frequency range when it caught something unexpected. A signal, faint but distinct, narrowband, structured. The duty operator, a veteran with 15 years of experience distinguishing between cosmic noise and genuine detections, flagged it immediately. Protocol required logging any unusual emission, cataloging its characteristics, and determining whether it originated from a known source or required further investigation. This signal didn't match any known spacecraft beacon. It didn't correspond to any scheduled transmission. It appeared to be coming from empty space. The coordinates were calculated within minutes. The signal originated from a region of sky containing only one object of interest, 3, I Atlas, the interstellar visitor that had been causing quiet concern among astronomers for weeks. The object was still millions of kilometers from Earth, receding slowly on its hyperbolic trajectory, supposedly just another piece of cosmic debris passing through our neighborhood. But now, it was broadcasting. The operator immediately notified the station supervisor. The supervisor contacted the Jet Propulsion Laboratory. JPL alerted NASA headquarters. Within 30 minutes of detection, a secure teleconference connected key personnel across multiple facilities. The signal was still active, still transmitting, still following its strange, repeating pattern. If the signals aren't random, someone made them. The recording captured by Goldstone showed a carrier wave at 1,420 megahertz, the hydrogen line, one of the most significant frequencies in radio astronomy. This is the frequency at which neutral hydrogen atoms emit radiation, creating a natural background hum that pervades the universe. It's also the frequency that scientists have long suggested as ideal for interstellar communication, a universal wavelength that any technological civilization would recognize as important. But this wasn't the diffuse emission of hydrogen clouds. This was a narrow-band signal, concentrated in a frequency range of less than 1 hertz. Natural processes don't produce such precise signals. Astrophysical phenomena, pulsars, masers, plasma interactions create radio emissions across broad frequency ranges or with characteristic spectral signatures that identify their sources. A signal, this narrow, this stable, this focused, requires either extraordinary natural coincidence or deliberate generation. The modulation pattern was what made it remarkable. The signal didn't maintain constant amplitude. Instead, it pulsed. The intensity rose and fell in a regular rhythm, each pulse lasting approximately 6 seconds, followed by silence, then another pulse. But the silence between pulses wasn't constant. The first gap was 2.6 seconds, the second gap was 4.2 seconds, the third gap was 6.8 seconds, the fourth gap was 11 seconds. Someone at JPL recognized it immediately. Those aren't random intervals. They're Fibonacci numbers converted to time measurements. Each gap equals the sum of the 2 preceding gaps, multiplied by some constant factor. 1, 1, 2, 3, 5, 8, 13. The ancient sequence discovered by medieval mathematicians but inherent to the structure of nature itself. It appears in the spiral of galaxies, the arrangement of sunflower seeds, the proportions of nautilus shells. It's a mathematical signature of organic growth and natural pattern. Or a deliberate message saying, "We understand mathematics too." The Goldstone detection lasted 18 minutes before the signal ceased abruptly. But by then, other facilities had been alerted. The Deep Space Network operates 3 complexes positioned around the globe: Goldstone in California, Madrid in Spain, and Canberra in Australia. This placement ensures that at least one facility always has line of sight to any point in space as Earth rotates. If the signal was real and persistent, the other stations would detect it when their antennas swept across the source coordinates. Madrid confirmed detection 4 hours later, when Earth's rotation brought 3 I-Atlas into their observable sky. The signal characteristics matched Goldstone's recording precisely. Same frequency, same modulation pattern, same Fibonacci timing. The Spanish operators tracked it for 22 minutes before it stopped. Canberra detected it 9 hours after that. Same signal, same pattern. 17 minutes of transmission, then silence. 3 independent facilities, 3 separate detections, identical characteristics. The probability of this being random interference or equipment malfunction approached 0. The signal was real. It was coming from the direction of 3 I-Atlas, and it was mathematical. If the signals aren't random, someone made them. NASA's public response was swift and carefully calibrated. Within 24 hours of the first detection, the agency issued a brief statement through its standard communication channels. The statement acknowledged that unusual radio emissions had been detected from the vicinity of interstellar object 3 I-Atlas, and that analysis is ongoing to determine the source and nature of these emissions. The statement emphasized that preliminary investigation suggests multiple potential explanations, including instrumental artifacts and natural astrophysical phenomena. The language was deliberately vague, technically accurate, but informationally empty. It confirmed something had been detected without revealing what that something might be. It acknowledged uncertainty, without conveying the level of excitement and concern rippling through the scientific community. It was a holding statement, a placeholder designed to acknowledge public interest while buying time for deeper analysis. Behind the scenes, the response was anything but calm. Secure conference calls connected astronomers, engineers, intelligence analysts, and policy officials. Data was encrypted and classified. Access to the raw recordings was restricted to personnel with appropriate clearances. The normal practice of sharing interesting astronomical detections through open channels, posting data to public archives, distributing information through astronomer networks was suspended. This signal was being treated differently. The decision to restrict access came from high levels. According to individuals familiar with the discussions, the reasoning was straightforward. If the signal was indeed from an artificial source, its implications extended far beyond science. This would be first contact, evidence of extraterrestrial intelligence, proof that humanity is not alone. Such a discovery required careful handling, deliberate disclosure, and coordination across government agencies. Premature release of ambiguous data could create panic or misinterpretation. Better to analyze thoroughly, understand completely, and then communicate clearly. But secrets have a way of escaping containment, especially in the digital age. Within 48 hours of the initial detection, information began leaking through multiple channels. Someone with access to the classified data started sharing fragments, not complete recordings, but descriptions, measurements, implications. These leaks appeared on encrypted messaging platforms, astronomy forums, and social media accounts associated with space research communities. One leaked document, purportedly from an internal JPL briefing, contained a single devastating sentence: signal characteristics inconsistent with all known natural radio sources. Artificial origin hypothesis cannot be dismissed and may be preferred explanation pending further analysis. If the signals aren't random, someone made them. Amateur radio astronomers became aware of the situation through their own observations, independent of NASA's official activities. The global community of radio enthusiasts includes thousands of individuals operating sensitive receiving equipment, monitoring the sky for interesting signals, participating in citizen science projects. Many of these observers had been tracking 3I Atlas as it passed through the inner solar system, hoping to detect radio emissions that might reveal something about the object's composition or behavior. Several amateur operators reported detecting transient signals from the object's coordinates, though their equipment lacked the sensitivity to capture the full detail that professional facilities observed. The amateur detections were described as brief bursts of increased noise or possible structured emissions in the frequency range around the hydrogen line. Individually, these reports might have been dismissed as wishful thinking or equipment errors. Collectively, they provided independent confirmation that something unusual was happening. One amateur astronomer, operating a modest radio telescope array from a rural location in New Mexico, posted detailed observations to an online forum. The post described detecting regular pulse patterns correlated with 3 I-Atlas transit times, and noted that the timing between pulses appears non-random and potentially structured. The observer had been recording continuously for several days and had captured multiple instances of the signal, enough to perform basic statistical analysis. "I ran the intervals through pattern recognition software," the post explained. "The timing doesn't match any known pulsar, doesn't correspond to satellite interference patterns, and shows sequential progression consistent with mathematical series. I don't want to speculate beyond what the data shows, but this doesn't look like noise. It looks like counting." The post included screenshots of waveform analysis, spectrograms showing frequency distribution over time, and tables of measured intervals. The quality was amateur, but the methodology was sound. Other members of the forum examined the data and reached similar conclusions. The signal showed structure. The intervals followed mathematical progression. Something about 3 I-Atlas was producing non-random radio emissions. Within days, the forum post had been viewed thousands of times, shared across social media, and picked up by space news outlets. The story was escaping NASA's control, spreading through networks the agency couldn't contain. The official narrative of ongoing analysis and multiple potential explanations was being contradicted by independent observers who had captured their own data and drawn their own conclusions. If the signals aren't random, someone made them. The comparison to the WOW signal was inevitable. In August 1977, a radio telescope at Ohio State University detected a powerful narrowband signal from deep space. The signal lasted 72 seconds, the maximum time the telescope's beam could remain pointed at any fixed location as Earth rotated. The signal was so unusual, so strong, so clearly artificial in character, that the astronomer reviewing the computer printout wrote, "Wow," in the margin next to the data spike. That annotation gave the signal its name and launched decades of speculation about whether humanity had briefly detected a transmission from an alien civilization. The WOW signal was never detected again. Despite numerous follow-up observations using more sensitive equipment, the source has remained silent. Skeptics argue it was probably terrestrial interference, a satellite, an aircraft, some human-generated emission that briefly passed through the telescope's field of view and happened to mimic an extraterrestrial signal. Believers counter that the signal's characteristics were inconsistent with known terrestrial sources and that its frequency, intensity, and narrowband nature all suggested artificial origin. The debate has continued for nearly half a century without resolution. The WOW signal represents both the promise and frustration of SETI, the search for extraterrestrial intelligence. It's tantalizing evidence that we might have briefly heard something extraordinary, or it's a reminder that the universe is full of ambiguous phenomena that can mislead even careful observers. The signals from 3 I-Atlas differed from the WOW signal in crucial ways, they repeated. They were detected by multiple facilities. They showed mathematical structure. And most significantly, they appeared to originate from a physical object whose location could be tracked and observed. This wasn't a single unexplained event from an unknown source. This was persistent emission from a specific target that was already under intensive scrutiny for other anomalous characteristics. The comparison to historical signal detections didn't stop with WOW. Researchers began compiling lists of other unusual radio observations that had defied easy explanation. The Kepler, 438b narrowband anomaly, a brief series of structured radio pulses detected during observations of an exoplanet system. The Galileo spacecraft's artifact debate disputed claims that Europa's magnetic field measurements contained non-random patterns suggesting subsurface activity or possibly even technology. The Voyager 2 glitch of 2010, a period when the spacecraft's data transmission briefly switched to an unknown format before spontaneously correcting itself. Each of these incidents had been investigated, analyzed, and ultimately explained away through conventional means or dismissed as inconclusive. But taken together, they formed a pattern of their own, a history of brief, ambiguous encounters with phenomena that momentarily suggested intelligence before slipping back into uncertainty. The signals from 3I Atlas threatened to break that pattern, to finally provide definitive evidence that would transform speculation into fact. If the signals aren't random, someone made them. The mathematical analysis of the signal timing was performed by multiple independent teams using different methodological approaches. All reached similar conclusions. The probability of the observed pattern occurring through random natural processes was vanishingly small. The Fibonacci sequence, while common in nature's physical structures, doesn't appear in the timing of astronomical radio emissions. Pulsars pulse regularly or chaotically, but not in mathematical progressions. Masers amplify specific frequencies, but their intensity variations don't follow numerical sequences. No known natural phenomenon produces radio emissions with Fibonacci-timed intervals. One analysis, conducted by statisticians at a major research university, applied rigorous randomness testing to the signal timing data. They use standard algorithms designed to detect non-random patterns in numerical sequences tests, originally developed for cryptography and random number generation validation. The signal timing failed every test. It wasn't random. It showed clear structure, clear pattern, clear intentionality. The null hypothesis that these intervals are randomly generated by natural processes can be rejected with confidence exceeding 99.99%, the analysis concluded. The observed pattern is statistically indistinguishable from an intentionally constructed sequence based on Fibonacci progression. While this does not definitively prove artificial origin, it provides strong evidence that the signal timing is not the product of chance. Other researchers approach the question from different angles. Information theorists analyze the signal using metrics designed to quantify complexity and structure. Their analysis showed that the signal contained information. It wasn't just noise or random fluctuation, but carried a measurable amount of non-random content. The amount of information was small, equivalent to just a few bits, but its mere presence indicated that the signal could potentially encode a message or serve as a beacon. If you wanted to create a signal that would be immediately recognizable as artificial to any observer with basic mathematical knowledge, this is exactly what you would do, explained one information theorist in a leaked technical memo. You would use a carrier frequency that has universal significance like the hydrogen line. You would modulate it in a simple pattern that demonstrates understanding of mathematics like Fibonacci numbers. You would transmit periodically to allow multiple detection opportunities. This signal follows that template perfectly. The technical consensus was forming. This was either the most extraordinary cosmic coincidence in astronomical history, or it was a deliberate transmission from a technological source. Natural explanations required increasingly contrived scenarios and unlikely combinations of circumstances. Artificial origin, by contrast, explained all observed characteristics with a single straightforward hypothesis. If the signals aren't random, someone made them. The equipment noise hypothesis was investigated thoroughly because eliminating mundane explanations is a prerequisite for claiming extraordinary discoveries. Perhaps the signal wasn't coming from space at all. Perhaps it was generated within the receiving equipment itself, a malfunction in amplifiers, oscillators, or digital processing systems that created the appearance of a structured signal where none existed. The Deep Space Network's engineers conducted comprehensive testing. They examined calibration data, reviewed maintenance logs, tested backup systems, and performed controlled experiments designed to reproduce the signal characteristics through equipment malfunction. They simulated various failure modes, amplifier oscillations, timing circuit glitches, interference between signal processing stages, software bugs in pattern recognition algorithms. None of these tests produced signals matching the observed characteristics. The fact that 3 geographically separated facilities detected identical signals was particularly significant. The DSN stations use similar but not identical equipment, built at different times by different contractors, maintained by different personnel. A hardware malfunction would have to affect all 3 systems in exactly the same way to produce identical false signals. The probability of this was effectively 0. Environmental interference was also considered. Radio telescopes operate in electrically noisy environments. Satellites pass overhead. Aircraft transmit navigation signals. Cell towers and communication networks fill the electromagnetic spectrum with artificial signals. Military radars sweep the sky. All of these sources can potentially contaminate astronomical observations if they fall within a receiver's frequency range and sensitivity window. But the Deep Space Network facilities are located in radio quiet zones, deliberately positioned far from population centers and protected by regulations that restrict nearby transmissions. The signal frequency, 1,420 MHz, falls within a protected band where deliberate transmission is internationally prohibited to preserve astronomical observations. And the signal's timing pattern, identical across 3 continents, couldn't be explained by local interference sources that would differ at each location. The equipment noise hypothesis failed every test. The signal was real. It was coming from space. It was originating from the coordinates of 3I Atlas. If the signals aren't random, someone made them. The coded propulsion system hypothesis emerged from researchers trying to imagine non-biological explanations for artificial signals. Perhaps 3I Atlas was indeed a technological object, but not a vessel carrying intelligent beings. Perhaps it was an automated probe, a sophisticated machine following programmed instructions without conscious intent. The signals might not be messages intended for external receivers, but rather internal. Telemetry, diagnostic transmissions, navigation updates, system status reports being broadcast by the probe for its own operational purposes. This hypothesis had precedent. Human spacecraft constantly transmit telemetry data, measurements of their position, velocity, temperature, power status, and countless other parameters. These transmissions allow ground controllers to monitor spacecraft health and performance. A sufficiently advanced automated probe might broadcast similar information not for the benefit of human receivers, but for its own creators or for other components of an interstellar exploration network. The mathematical pattern in the timing could serve a functional rather than communicative purpose. Fibonacci sequences have useful properties for error detection and correction in digital communications. Using mathematically structured timing intervals could help a receiving system synchronize with transmissions, distinguish signal from noise, and recover data accurately. What appeared to human observers as a deliberate message might actually be the equivalent of a carrier tone or clock signal technical infrastructure rather than content. The propulsion system angle suggested that the radio emissions might be byproducts of the object's maneuvering systems. Ion drives and other electric propulsion technologies generate electromagnetic emissions as they operate. Plasma, electromagnetic fields, and accelerated particles all create radio noise. If 3I Atlas was using advanced propulsion to navigate through the solar system, the observed signals might be the electromagnetic signature of that propulsion system, activating and deactivating in controlled sequences. The hypothesis was plausible, but raised as many questions as it answered. If the signals were functional, telemetry, or propulsion byproducts, why were they concentrated at the hydrogen line frequency? Why did they pulse with mathematical timing rather than continuously? And most troubling, if this was routine operation of an automated system, did that mean 3I Atlas was still active, still maneuvering, still executing some programmed mission as it passed through our solar system? If the signals aren't random, someone made them. The directed data burst hypothesis was the most unsettling possibility. Perhaps the signals weren't random noise, weren't telemetry, weren't propulsion signatures. Perhaps they were exactly what they appeared to be. Deliberate transmissions intended to be received, decoded, and understood. A message, transmitted at a frequency and in a pattern designed to be universally recognizable, sent by an intelligence that wanted to announce its presence. But if this was a message, what did it say? The Fibonacci timing provided mathematical structure, but beyond demonstrating knowledge of this sequence, it didn't convey specific information. The signal was too simple, too brief, too repetitive to contain complex data. If the creators of 3i Atlas wanted to communicate detailed information, they would need much longer transmissions with much more sophisticated encoding. Unless the simplicity was the point. Unless the message wasn't meant to convey specific facts or instructions, but simply to say, we exist, we are intelligent, we understand mathematics, we are here. A cosmic calling card, an announcement of presence, a signal that serves no purpose except to be noticed and recognized for what it is. This interpretation suggested that 3i Atlas wasn't just passing through our solar system by chance. It was visiting deliberately, observing Earth, and announcing its presence through signals that any scientifically literate civilization would recognize as artificial. The probe, if that's what it was, might be gathering data about our planet, our species, our technology, while simultaneously revealing itself to us through these periodic broadcasts. The implications were profound. If an extraterrestrial intelligence had sent a probe to our solar system and was deliberately signaling its presence, this represented intentional contact. Not the passive detection of signals from distant stars, but active engagement from a visitor in our immediate cosmic neighborhood. First contact, happening not through radio telescopes listening to the void, but through an object that came here specifically to be found. If the signals aren't random, someone made them. The pattern recognition suppression allegations emerged from leaked internal documentation that appeared online through anonymous channels. The documents, marked with classification headers and administrative watermarks, described internal NASA discussions about how to handle the signal detections publicly. According to these materials, there was significant debate about whether and when to disclose the mathematical nature of the signal timing. One memo fragment read, "Public release of timing analysis should be carefully considered. Confirmation of Fibonacci progression will immediately lead to speculation about artificial origin. Recommend continued emphasis on uncertainty and multiple hypotheses pending completion of comprehensive review." Another document outlined communication protocols. Media inquiries regarding signal structure should be directed to designated spokespersons. Technical staff are reminded that detailed discussion of ongoing analysis is restricted pending interagency coordination. The leaked materials suggested that NASA and partner organizations were not actively hiding information, but were deliberately slowing its release, controlling the narrative, managing public perception. The goal appeared to be preventing premature conclusions while allowing time for thorough analysis and coordination with other government entities. But to outside observers, especially those who had detected the signals independently or had access to fragments of the classified data, this approach looked like suppression. The phrase pattern recognition suppression appeared in online discussions among skeptics who believed NASA was intentionally downplaying the mathematical structure in the signals. The allegation was that the agency had confirmed the Fibonacci timing but was reluctant to acknowledge it publicly because doing so would make the artificial origin hypothesis difficult to dismiss. By emphasizing uncertainty and waiting for comprehensive review, NASA could delay the moment when it might have to publicly admit that 3i Atlas appeared to be broadcasting deliberate signals. Whether this constituted suppression or simply prudent caution was a matter of interpretation. Scientific institutions face constant tension between the desire to share discoveries quickly and the need to verify findings thoroughly. Premature announcements of questionable results damage credibility and confuse the public. But excessive caution can also be criticized as obstruction. especially when independent observers are reaching conclusions that official sources won't confirm. The debate played out across astronomy forums, social media platforms, and science journalism outlets. Some defended NASA's careful approach, arguing that claims of extraterrestrial intelligence require extraordinary evidence and methodical verification. Others accused the agency of paternalism, suggesting that the public deserved to know the facts and could handle uncertainty without requiring pre-digested conclusions from authorities. If the signals aren't random, someone made them. Avi Loeb, the Harvard astronomer who had previously suggested that the interstellar object Oumuamua might be artificial, weighed in on the 3I Atlas signals with characteristic directness. In a series of blog posts and media interviews, he argued that the scientific community should take the possibility of artificial origin seriously rather than dismissing it reflexively. We have an object exhibiting anomalous trajectory, unusual composition, unexpected thermal characteristics, and now mathematical radio emissions, Loeb stated in one interview. At what point does parsimony suggest that the simplest explanation is that this object is technological rather than natural? We're bending over backward to invent increasingly contrived natural scenarios when there's an obvious hypothesis staring us in the face. Loeb's analysis focused on what he called probabilistic, non-random emission behavior, his technical term for signals that showed patterns inconsistent with random processes. He calculated the probability of natural radio emissions spontaneously organizing into Fibonacci-timed pulses and arrived at numbers so small they bordered on impossibility. The probability is comparable to randomly typing Shakespeare, he wrote. Technically possible, but so unlikely that any reasonable observer would conclude the text was written intentionally rather than produced by chance. The same logic applies here. These signals show intentional structure. He addressed the criticism that claiming alien technology based on ambiguous data was scientifically irresponsible. Science advances by following evidence, he argued. We form hypotheses based on observations, then test those hypotheses against additional data. The artificial origin hypothesis explains all observed characteristics of 3I Atlas with a single coherent framework. Natural explanations require multiple unrelated coincidences, which is more scientifically justified. Loeb's comments sparked renewed debate within the astronomical community. Some colleagues praised his willingness to explore unconventional ideas and challenge conservative assumptions. Others criticized what they saw as premature speculation, insufficiently grounded in rigorous analysis. The division reflected deeper philosophical differences about how science should handle potentially revolutionary discoveries, whether to emphasize skepticism and caution or to embrace bold hypotheses and risk being wrong. But beneath the public debate, even Loeb's critics privately acknowledged that the evidence was becoming difficult to explain conventionally. The signals added another layer to an already complex puzzle. Each new observation of 3I Atlas revealed something unexpected, something that pushed the boundaries of natural explanation. The trajectory anomalies, the thermal excess, the structural features, and now the mathematical radio emissions individually, each might be dismissed or explained away. Collectively, they formed a pattern that increasingly suggested something other than a random chunk of rock and ice. If the signals aren't random, someone made them. The coordination blackout across partner observatories occurred suddenly and without public explanation. Within hours of the Canberra detection confirming the signal pattern, access to deep space network data was restricted. The normal practice of sharing raw observational data with partner institutions and researchers was suspended for observations related to 3I Atlas. Public data archives stopped updating, real-time feeds went dark. Requests for observation time were denied or delayed. The blackout extended beyond NASA facilities. The European Space Agency's radio astronomy network, Japan's JAXA deep space communication systems, and several major university observatories all simultaneously implemented access restrictions. Coordination across these organizations required high-level discussion and agreement, suggesting that the decision came from governmental rather than purely scientific levels. Amateur observers noticed immediately. Forums dedicated to tracking DSN operations reported that the network had entered what one user described as silent mode, continuing to operate, but no longer providing public visibility into its activities. The tracking websites that normally showed which spacecraft were being contacted by which antennas displayed only generic placeholders. The data streams that allowed researchers to monitor ongoing observations were offline. "Something big is happening, and they don't want us to see it," posted one observer. "The network doesn't just go dark like this. Even during classified military satellite operations, there are indicators that something is happening. This feels different. This feels like they're coordinating something across multiple agencies simultaneously." The blackout suggested several possibilities. Perhaps additional signals had been detected that were even more definitive than the initial Fibonacci sequence. Perhaps attempts to communicate with the object had succeeded or failed in ways that required careful coordination to manage. Perhaps international agreements were being negotiated about how to handle the situation. Or perhaps the data was simply being analyzed exhaustively before any additional public release. Regardless of the reason, the effect was to increase public suspicion and speculation. The appearance of coordination and secrecy, even if justified by legitimate scientific or security concerns, fed narratives about cover-ups and hidden information. Transparency advocates argued that the public had a right to know what was being detected and discussed. Security officials countered that premature disclosure of ambiguous data could create panic or provide incomplete information that would be widely misinterpreted. The tension between these positions reflected a fundamental challenge that would only intensify if the signals proved to be genuinely artificial. How does humanity collectively process and respond to evidence of extraterrestrial intelligence? Who decides what information to release and when? How do we balance scientific openness with security concerns? These questions had been theoretical for decades. Now they were becoming practical and urgent. If the signals aren't random, someone made them. The historical analysis of claimed signal detections provided context for understanding the current situation. Over the decades since SETI began systematically searching for extraterrestrial intelligence, numerous candidate signals had been detected, investigated, and ultimately explained or dismissed. The process had become almost routine. Exciting initial detection, followed by careful analysis, followed by identification of a mundane source or inability to confirm the signal through repeat observations. The pattern had created a kind of fatigue within the astronomical community. Most researchers had learned to respond to claimed signal detections with automatic skepticism, assuming that any unusual observation would eventually be explained conventionally. This cautious approach was scientifically sound. Extraordinary claims require extraordinary evidence, but it also risked dismissing genuinely anomalous phenomena through reflex rather than rigorous analysis. The WOW signal remained the canonical example. Despite decades of follow-up observations, the source had never repeated and the signal had never been definitively explained. Skeptics pointed to this as evidence that the signal was probably terrestrial interference or instrumental artifact. If it were a genuine extraterrestrial transmission, it should recur. Believers countered that a single transmission from a distant source might never be detected again, simply due to the vastness of space and the improbability of pointing telescopes at exactly the right location, at exactly the right time. The Kepler 438b narrowband anomaly had briefly excited researchers when narrowband radio emissions were detected from the vicinity of an exoplanet system located about 470 light-years from Earth. The signals showed some structure and appeared to originate from the planetary system rather than background sources. But subsequent analysis revealed that the signals were sporadic, inconsistent, and could be explained by magnetic activity in the star or possibly interference from satellites in Earth orbit. The detection was never confirmed and eventually faded from serious consideration. The Galileo artifact debate concerned data from Jupiter's moon Europa. During close flybys, The spacecraft's magnetometer detected unusual patterns in Europa's induced magnetic field variations that some researchers argued showed non-random structure, potentially indicating subsurface electromagnetic activity. Speculative interpretations suggested that organized currents in Europa's ocean, perhaps generated by biological or even technological sources, might explain the patterns. But mainstream analysis concluded that the magnetic field variations were consistent with natural interactions between Europa's ocean and Jupiter's magnetosphere, requiring no exotic explanations. The Voyager 2 glitch of 2010 occurred when the spacecraft, operating in the outer solar system, suddenly began transmitting data in an unknown format. Engineers at JPL scrambled to understand what had happened. The spacecraft appeared to have spontaneously switched to a different telemetry mode without commands from Earth. Some observers speculated wildly about the spacecraft being hijacked by external intelligence or encountering something in space that altered its programming. The actual explanation was more mundane. A single bit flip in the spacecraft's memory, probably caused by a cosmic ray strike, had changed a memory location that controlled data formatting. A software patch uploaded from Earth corrected the problem. Each of these historical cases illustrated both the challenges and the risks of signal detection. The challenge was distinguishing genuine anomalies from the countless sources of false positives, equipment glitches, interference, misunderstood natural phenomena, and statistical flukes. The risk was either claiming discoveries prematurely, damaging scientific credibility, or dismissing genuine findings through excessive skepticism, missing opportunities to recognize genuinely extraordinary phenomena. The signals from 3I Atlas existed in this complex landscape. They were stronger and more structured than most historical candidates. They repeated across multiple facilities. They showed clear mathematical pattern. They originated from a specific object that was already exhibiting other anomalous characteristics. But they were also ambiguous enough, brief enough, and strange enough that definitive interpretation remained elusive. If the signals aren't random, someone made them. The bandwidth analysis provided additional evidence for artificial origin. Radio emissions from natural astrophysical sources typically have characteristic bandwidth, the range of frequencies over which the signal is distributed. Pulsars emit across broad frequency ranges. Masers concentrate energy at specific frequencies, but with natural line widths determined by quantum mechanics. Plasma emissions spread across frequency spectra according to the temperature and density of the emitting material. The 3I Atlas signal was extraordinarily narrow. Spectral analysis showed that more than 90% of the signal energy was concentrated within a bandwidth of less than 1 Hz, centered on 1,420.4058 MHz, the precise frequency of the hydrogen line corrected for the object's velocity through space. A bandwidth this narrow required either extremely unusual natural conditions or deliberate generation through a stabilized transmitter. Natural processes don't produce signals this narrow, explained one radio astronomer in a technical analysis that circulated among researchers. Astrophysical masers can be relatively narrow, but they're still much broader than this. To get a signal this precise, you need a coherent source, something generating electromagnetic waves with stable phase and frequency, like a transmitter with a crystal-controlled oscillator. This is engineered narrowness. The frequency stability was equally remarkable. Over the course of multiple detections spanning several days, the signal remained locked to the hydrogen line frequency with precision better than 1 part per million. Natural sources would show drift due to thermal variations, motion of the source, or changes in the emission mechanism. This signal remained absolutely stable, suggesting active frequency control maintaining exact wavelength. The combination of extreme narrowness and perfect stability left little room for natural explanation. The signal characteristics were consistent with a carefully engineered transmitter designed to broadcast at a universally significant frequency with maximum detectability and minimum ambiguity. It was exactly what SETI researchers had been searching for, a signal that would be immediately recognizable as artificial to any technologically capable civilization. If the signals aren't random, someone made them. The political dimension began to emerge as governments realized they might need to coordinate responses to a genuinely anomalous phenomenon. Behind the scenes, communication between space agencies evolved into discussions between diplomatic and intelligence organizations. If 3I Atlas was broadcasting signals, if those signals appeared artificial, if the object might genuinely be an alien probe, then the situation transcended science and became a matter of policy, security, and international coordination. The United Nations Office for Outer Space Affairs, normally concerned with satellite coordination and peaceful use of space, became involved in discussions about protocols for responding to extraterrestrial contact. Documents existed outlining theoretical response procedures, plans developed decades earlier by committees that had never expected to actually use them. Now those plans were being reviewed, updated, and potentially prepared for implementation. The protocols emphasized coordination, caution, and peaceful intent. They specified that any confirmed detection of extraterrestrial intelligence should be shared with the international community, that no single nation should claim exclusive right to respond, and that any reply transmission should be coordinated through international consultation. But the protocols were vague on practical details. Who decides when evidence is sufficient to trigger international notification? What constitutes confirmed detection? How should information be shared with the public? The documents provided principles, but not procedures. Military and intelligence agencies quietly assessed potential security implications. If 3I Atlas was a probe from an advanced civilization, what did its presence mean for Earth's security? Was observation benign scientific curiosity, or preliminary reconnaissance? Should the object be treated as a potential threat requiring defensive preparation? Or would militaristic responses be counterproductive, potentially conveying hostility toward visitors who might be peaceful? These questions had no clear answers. The object had shown no hostile action. It simply observed and transmitted. But the capability to cross interstellar distances and navigate through another species' solar system implied technological sophistication far beyond current human achievement. Any civilization capable of sending probes to other star systems would possess technology that might seem like magic to us, capabilities we couldn't predict or defend against if they chose hostility. Defense planners developed contingency scenarios, not because they believed 3I Atlas posed immediate danger, but because planning for possibilities is what defense organizations do. What if the object released smaller probes? What if it moved toward Earth? What if its signals were attempts to hack or map our telecommunications networks? What if other objects were approaching undetected? The scenarios multiplied, each more speculative than the last, but each requiring some level of consideration and preparation. If the signals aren't random, someone made them. The linguistic analysis attempted to determine if the signals might contain encoded information beyond the mathematical timing pattern. Cryptographers, linguists, and information theorists examined the signal characteristics, looking for subtle variations that might carry data changes in amplitude, frequency modulation, polarization, or any other parameter that could be used to encode information. The analysis was complicated by the signal's simplicity. Unlike the complex, information-dense transmissions that carry data for human spacecraft, the 3I Atlas signals appeared to consist of nothing more than carrier waves with amplitude modulation following the Fibonacci timing pattern. There were no obvious secondary structures, no additional layers of encoding, no frequency shift keying or phase modulation that might indicate data transmission. But absence of obvious encoding didn't mean absence of information. Perhaps the timing itself conveyed meaning beyond simply demonstrating mathematical knowledge. The specific Fibonacci numbers chosen for the intervals, which numbers in the sequence, how many repetitions might carry significance. The duration of transmission sessions might be meaningful. The intervals between transmission sessions might encode data. Analysts constructed databases of the observed transmissions, cataloging every measurable parameter. They looked for patterns in patterns, searching for second-order structures that might reveal themselves through statistical analysis. They compared the signals to known communication protocols, looking for similarities to schemes humans had devised for encoding information in simple carrier waves. The results were inconclusive. Some analysts claimed to see hints of structure that might suggest additional encoding. Others argued that the searches were finding patterns in noise, the human tendency to discover meaning in randomness. Without a key, some way to understand the language or protocol being used, decryption was effectively impossible. If the signals did contain a message beyond the basic mathematical announcement, we lacked the context to decode it. One linguist, reviewing the debate, offered a philosophical perspective. Maybe the message is the transmission itself. Maybe the point isn't to convey specific information, but simply to say, we're here, we're intelligent, we see you. First contact doesn't require complex language. It just requires unambiguous evidence of intentionality. These signals provide that. If the signals aren't random, someone made them. The observation schedule intensification reflected the astronomical community's recognition that 3I Atlas represented an unprecedented opportunity. Whether the object was natural or artificial, whether the signals indicated intelligence or some exotic unknown phenomenon, it demanded every available resource for observation while it remained accessible. Major observatories redirected their instruments. Radio telescopes maintained continuous watch. Optical telescopes captured high-resolution images. Infrared satellites monitored thermal emissions. Radar installations bounced signals off the object's surface. The most comprehensive observation campaign in history was being conducted on a single target, driven by the knowledge that the object would eventually depart beyond the range of detailed study. The coordination required complex negotiation. Telescope time is precious, allocated months or years in advance to specific research projects. Redirecting facilities to observe 3I Atlas meant displacing other observations, disappointing researchers whose approved projects were being postponed. But the decision was made at the highest levels of major observatories. Whatever 3I Atlas was, it took precedence. Some observations remained classified, their results shared only among cleared personnel. Other data was released to the broader scientific community, enabling independent analysis by researchers worldwide. The balance between security and openness was carefully managed, with information released when it was deemed scientifically significant but unlikely to cause public alarm, while more sensitive findings remained restricted. Amateur astronomers participated where they could. Backyard observers contributed visual observations, tracking the object's position and brightness. Amateur radio operators monitored frequencies, hoping to detect additional transmissions. Citizen science projects organized distributed observation campaigns, coordinating thousands of participants across the globe. The response demonstrated humanity's collective curiosity and determination to understand the mystery passing through our cosmic neighborhood. If the signals aren't random, someone made them. The signal timing evolution became apparent as additional transmissions were detected and cataloged. The initial observations had captured Fibonacci-timed pulses extending through the first several numbers in the sequence: 1, 1, 2, 3, 5, 8. But subsequent transmissions showed variations. Sometimes the sequence continued further: 13, 21, 34. Sometimes it repeated at different cycle lengths. Sometimes it paused at specific numbers before continuing. The variations suggested that the transmissions were not simply a recorded loop playing endlessly, but rather an active signal being generated and controlled. If the pattern was truly artificial, someone or something was choosing when to transmit, how long to transmit, and what pattern to transmit. The signals were responsive, dynamic, intentional. One particularly intriguing transmission occurred when Earth-based transmitters had been attempting to signal 3I Atlas. A coordinated effort involving multiple radio telescopes had broadcast mathematical sequences toward the object prime numbers, Fibonacci numbers, pi, hoping to elicit a response if the object was capable of receiving and reacting. Approximately 6 hours after these transmissions, the round-trip light travel time to the object and back the 3-eye atlas signal pattern changed. Instead of the usual Fibonacci sequence, it transmitted prime numbers 2, 3, 5, 7, 11. Then it reverted to Fibonacci, then primes again. The timing and pattern suggested a response. Not proof 6 hours was a suspiciously convenient interval, and the pattern change might have been coincidental, but it was consistent with a probe that had received the Earth transmissions, processed them, and replied with acknowledgement. If deliberate, it represented the first two-way communication between humanity and an extraterrestrial intelligence, even if the content was nothing more than mathematical call and response. NASA declined to confirm that the pattern change constituted a response. Official statements emphasized that correlation does not imply causation, and that multiple transmission sessions have shown pattern variations that may or may not be related to Earth-based signals. But the careful language didn't hide the underlying excitement. Something about the object's behavior appeared reactive, adaptive, possibly communicative. If the signals aren't random, someone made them. The parallax measurements from multiple spacecraft throughout the solar system allowed precise determination of 3-eye atlas's distance and trajectory. By observing the object simultaneously from different locations, Earth-based telescopes, Mars orbiters, spacecraft in the asteroid belt, astronomers could triangulate its position with extreme accuracy. These measurements confirmed that the signals were definitely originating from the object itself, not from some background source that happened to align with its position as seen from Earth. The spatial localization was important for eliminating certain alternative hypotheses. Some skeptics had suggested that the signals might be coming from a previously unknown pulsar or other natural source that coincidentally appeared near 3-eye atlas's coordinates. But parallax observations showed that the signal source moved with the object as its position changed relative to background stars. The emissions were definitely associated with 3-eye atlas, not with something behind it or in the same line of sight. The precise position measurements also allowed accurate calculation of signal propagation delays. Radio waves travel at light speed, so the time delay between the object's location and Earth's receiving stations could be calculated and compared to observed timing. The calculations matched observation perfectly, confirming that the signals propagated at light speed as expected for radio waves traveling through space. This eliminated exotic hypotheses about faster-than-light transmission or signals propagating through alternative dimensions. Everything about the signal detection was consistent with conventional radio propagation from a source located at the physical position of 3-eye atlas. The signals were real electromagnetic transmissions from a real object in space. The mystery wasn't whether the signals existed, but what generated them. If the signals aren't random, someone made them. The power output calculations provided insight into the transmitter's capabilities. Based on the signal strength detected at Earth and the known distance to the object, physicists could calculate how much power the transmitter was radiating. The calculations showed that the signal was relatively weak, perhaps a few hundred watts, comparable to a small terrestrial radio station or a deep space probe's communications system. This power level was significant because it suggested intentional directionality. Broadcasting a signal in all directions equally would require enormous power to be detectable across interstellar distances. But a relatively weak transmitter could still be detected far away if the signal was beamed directionally, concentrated in a narrow cone towards specific targets rather than dispersed spherically. The 3-eye atlas signals appeared to be directional, pointing toward Earth during transmission sessions. When the object's geometry oriented appropriately, signals were detected. During other periods, when the object's orientation presumably pointed elsewhere, nothing was detected. This pattern suggested that the transmissions were being aimed deliberately toward our planet. If this interpretation was correct, it meant that whoever or whatever controlled the transmissions knew Earth was here and was choosing to signal toward us. This wasn't accidental leakage of internal communications or random broadcasting. This was directed contact, a deliberate attempt to be detected by observers on this specific planet. The implications were staggering. If true, it meant that some intelligence had sent a probe to our solar system specifically to observe Earth, and that probe was now announcing its presence through signals targeted at our world. We weren't discovering a random interstellar visitor. We were being visited, observed, and contacted. If the signals aren't random, someone made them. The ethical and philosophical debates intensified as the evidence accumulated. Scientists, philosophers, theologians, and policy experts engaged in discussions about how humanity should respond if the signals were confirmed as artificial. Should we transmit back? What should we say? Who decides what message to send on behalf of humanity? What are the risks of revealing our presence more fully than we already have? Some argued for active transmission of detailed information about human civilization, languages, science, art, culture. Others advocated caution, noting that we knew nothing about the intentions or nature of whoever might be listening. Revealing too much about ourselves might create vulnerabilities if the visitors were not benevolent. Perhaps silence was the safest response until we understood more. The debates echoed discussions that had been occurring in SETI communities for decades. The question of whether and how to respond to potential alien signals had been considered theoretically for years, but always in the abstract context of signals from distant stars that would take decades or centuries to reach. 3I Atlas changed the time frame dramatically. This wasn't a signal from light years away. This was a visitor here now, in our solar system, possibly waiting for response. Religious organizations grappled with theological implications. How did the existence of extraterrestrial intelligence fit with various religious traditions' understanding of humanity's place in creation? Different faiths reached different conclusions. Some saw alien visitors as consistent with divine creation of life throughout the universe. Others struggled to reconcile ancient texts with the reality of cosmic companionship. The public's reaction varied widely. Some people responded with excitement and wonder, thrilled by the possibility of first contact and eager to learn more. Others felt anxiety or fear, worried about the unknown intentions of visitors possessing technology far beyond human capabilities. Still, others remained skeptical, unconvinced by evidence they considered ambiguous and preferring to wait for more definitive proof before accepting extraordinary claims. If the signals aren't random, someone made them. The signal cessation occurred abruptly on a Wednesday afternoon. Observatories around the world that had been detecting periodic transmissions from 3I Atlas suddenly found only silence. The carrier wave disappeared. The Fibonacci pulses stopped. The hydrogen line frequency that had been active for days went dark. Initial speculation suggested equipment failure, but coordinated confirmation across multiple facilities ruled this out. All receivers were functioning normally. They simply weren't detecting signals anymore. The object had stopped transmitting. The timing of the cessation was analyzed exhaustively, searching for correlation with any other events. Had the object's trajectory changed? Had its orientation shifted? Had Earth-based attempts at communication triggered the silence? No clear causal relationship emerged. The transmissions simply ended, as mysteriously as they had begun. Some researchers interpreted the silence as completion of a programmed sequence. Perhaps the probe had finished its primary transmission cycle and moved on to other activities. Perhaps it had gathered sufficient data and was preparing to depart the solar system. Perhaps the signals had served their purpose, announcing presence, demonstrating intelligence, and were no longer necessary. Others viewed the silence with concern. Had something gone wrong with the object? Had we inadvertently triggered a defensive response by attempting communication? Had the probe detected something about Earth that changed its behavior? The absence of signals raised as many questions as the presence of signals had. The silence continued for days, then weeks. Observatories maintained watch, ready to detect any resumption of transmission. Radio astronomers pointed their antennas at the object's coordinates during every available observation window. Amateurs kept vigil from their backyard installations. But the hydrogen line remained quiet. Whatever 3i Atlas had been saying, it had finished saying it. If the signals aren't random, someone made them. The final trajectory showed that 3i Atlas was accelerating away from the inner solar system, heading back toward interstellar space along a hyperbolic escape trajectory. Its velocity was increasing faster than gravitational physics alone could explain, confirming that the object was using some form of propulsion to accelerate. The trajectory was precise, controlled, deliberate, the path of a vessel under navigation rather than a passive object drifting through space. Optical observations captured the object becoming progressively fainter as its distance increased. Within months, it would be too faint for most telescopes to detect. Within a year, it would be beyond the reach of even the most powerful facilities. Eventually, it would disappear completely, returning to the interstellar void from which it had emerged. Humanity was left with questions, with data, with memories of signals that had briefly suggested we were not alone. The evidence was compelling but not definitive. The signals had been real, structured, mathematical. They had appeared artificial by every analytical metric, but they had also been brief, ambiguous, open to interpretation. NASA's final official statement on the matter was carefully worded. Observations of interstellar object 3, I-Atlas, have provided valuable scientific data that will be analyzed for years to come. The object exhibited several unusual characteristics, including radio emissions that showed non-random timing patterns. While natural explanations for these emissions cannot be completely ruled out, the observed characteristics are consistent with technological origin. Further observation and analysis are ongoing, and we remain committed to sharing findings with the scientific community and the public as our understanding develops. The statement acknowledged the anomalies without claiming discovery. It left the door open to both natural and artificial interpretations. It satisfied no one completely, but avoided premature commitment to conclusions that might later require revision. If the signals aren't random, someone made them. The scientific papers began appearing in peer-reviewed journals months after the initial detections. Each paper addressed specific aspects of the observations: the trajectory analysis, the signal characteristics, the timing patterns, the statistical analysis, the attempts at communication. Each paper was careful, methodical, hedged with caveats and acknowledgments of uncertainty. But collectively, they painted a picture that was difficult to ignore. One particularly influential paper, published in Nature by an international collaboration of radio astronomers, analyzed the signal timing with extreme rigor. The abstract's final sentence read, "While we cannot definitively exclude all natural explanations, the probability that the observed timing patterns arose through random natural processes is less than 1 in 10 billion. We conclude that the artificial origin hypothesis warrants serious consideration and further investigation." Another paper in the Astrophysical Journal analyzed the trajectory and propulsion characteristics. The object designated 3i Atlas exhibits non-gravitational acceleration that cannot be explained by known cometary or solar radiation pressure effects. The magnitude and direction of acceleration are consistent with a low-thrust propulsion system. We cannot determine whether this propulsion is natural or technological, but we note that no natural mechanism has been identified that satisfactorily explains all observed characteristics. The accumulation of peer-reviewed literature created a foundation of legitimate scientific discussion. This wasn't fringe speculation or tabloid sensationalism. These were respected researchers at major institutions, publishing in prestigious journals, using rigorous methodology to analyze extraordinary data. The conclusions were tentative, the language was cautious, but the underlying message was clear. Something genuinely unusual had passed through our solar system, and we didn't fully understand what it was. If the signals aren't random, someone made them. The public perception shifted gradually from skepticism to wonder. As the scientific papers accumulated, as more data became available, as independent researchers confirmed the initial findings, the possibility that 3i Atlas might be artificial moved from conspiracy theory to mainstream consideration. Major news outlets covered the story seriously. Documentary producers created programs exploring the evidence. Educational institutions incorporated the case into curricula as an example of how science handles ambiguous data and extraordinary claims. Opinion polls showed increasing public acceptance that we might have been visited by an alien probe. The numbers varied by region, demographic, and question wording, but a consistent pattern emerged. Roughly half of respondents believed the evidence suggested artificial origin, while the other half remained unconvinced or undecided. Few people dismissed the possibility entirely. The data was too strong, too well documented, too thoroughly analyzed to ignore. The cultural impact extended beyond science. Artists created works inspired by the visitation. Authors wrote novels imagining the civilization that might have sent the probe. Musicians composed pieces capturing the eerie beauty of signals from the void. The mystery of 3I Atlas became embedded in human consciousness, a symbol of cosmic possibility and the limits of current knowledge. But for all the attention and analysis, the fundamental questions remained unanswered. Was it natural or artificial? If artificial, who made it and why? What did the signals mean beyond their mathematical structure? Was this our only visitor, or were others coming? And most haunting of all, if they were watching us, what did they see? If the signals aren't random, someone made them. The follow-up search began immediately. If 3I Atlas was indeed an artificial probe, there might be others. Perhaps interstellar civilization sends countless probes to explore the galaxy, and we happen to detect one. Perhaps our solar system is routinely visited by such objects, but most pass through undetected because we're not looking carefully enough. Perhaps careful systematic search would reveal more visitors. Astronomical surveys were initiated to search for additional interstellar objects. Existing detection programs were expanded and refined. New telescopes designed specifically to find faint, fast-moving objects were planned. The logic was straightforward. If one probe visited, others might follow. Vigilance and systematic observation might reveal a pattern of visitation we had previously missed. The search also extended to historical data. Astronomers began reanalyzing archival observations from past decades, looking for previously overlooked interstellar visitors. Perhaps Oumuamua and 3I Atlas weren't the first. Perhaps similar objects had passed through before but weren't recognized for what they were. Perhaps the archives contained evidence of earlier visits waiting to be discovered. The effort represented a transformation in how humanity monitored its cosmic neighborhood. What had been casual attention to occasional unusual observations became systematic surveillance. We were no longer passive recipients of whatever the universe happened to send our way. We were actively watching, searching, hoping to detect and understand visitors from beyond. If the signals aren't random, someone made them. The theoretical modeling explored what interstellar probe networks might look like. If a civilization wanted to explore the galaxy, what strategy would they use? How many probes would they send? How would the probes be distributed? What instructions would they follow? The questions generated fascinating analysis and creative speculation. One popular model suggested that advanced civilizations might send self-replicating probes, machines capable of reaching a star system, gathering resources, building copies of themselves, and dispatching those copies to new destinations. Such a strategy could explore the entire galaxy in a few million years, even with slower-than-light travel. If this approach was common among spacefaring civilizations, the galaxy might be filled with autonomous probes, each exploring and replicating according to ancient programming. Another model proposed that probes might be positioned at strategic locations to observe emerging civilizations. Perhaps certain star systems with potentially habitable planets were seeded with monitoring stations long ago, programmed to activate when signs of technology appeared. Earth's development of radio transmission, nuclear energy, and space travel might have triggered observational protocols in probes that had been waiting dormant for millennia. These models were speculation, but grounded in what we know about astronomy, engineering, and the constraints of interstellar travel. They represented humanity's attempt to understand how other intelligences might think, what strategies they might employ, what we might expect if we're being visited. The models also guided search strategies, where to look, what to look for, how to recognize artificial objects when we encounter them. If the signals aren't random, someone made them. The infrastructure development focused on improving humanity's capability to detect and study interstellar visitors. New telescopes were funded, detection algorithms were refined. International coordination was strengthened. The experience with 3i Atlas revealed gaps in our observation networks and capabilities that needed to be addressed. One key improvement involved response time. 3i Atlas had been detected when it was already relatively close to the inner solar system, leaving limited time for comprehensive observation before it receded beyond optimal range. Better detection systems capable of spotting interstellar objects earlier would provide more time for study months or years instead of weeks, allowing detailed observation campaigns and even potentially sending spacecraft for close-range investigation. Communications infrastructure was also enhanced. The experience of coordinating observations across dozens of facilities worldwide revealed bottlenecks and inefficiencies. New protocols were established for rapid data sharing, coordinated observation scheduling, and integrated analysis. If another interstellar visitor arrived, the response would be faster, more comprehensive, and more coordinated. The investments represented recognition that humanity had entered a new era. We were no longer isolated on a single planet, unaware of the larger cosmos. We were active participants in a universe that might contain many civilizations, many technologies, many mysteries. Our infrastructure needed to reflect this reality, to position us to detect, study, and potentially interact with whatever we might encounter. If the signals aren't random, someone made them. The years passed, and 3i Atlas faded from immediate public consciousness, though it remained central to scientific discussions. The data continued to be analyzed. New papers appeared regularly. Conferences devoted entire sessions to debating the evidence and its implications. The case became the touchstone for discussions about how to recognize and respond to potentially artificial phenomena. But no definitive answer emerged. The evidence remained compelling but ambiguous. Natural explanations, while requiring increasingly contrived scenarios, could never be completely ruled out. Artificial origin, while explaining the observations elegantly, could never be absolutely proven without direct examination or explicit communication from the object's creators. The situation reflected a fundamental challenge in the search for extraterrestrial intelligence. How much evidence is enough? What level of certainty is required before claiming discovery? Science demands rigor and reproducibility, but unique historical events, like the passage of an interstellar visitor, don't repeat on demand. We get one chance to observe, one data set to analyze, one opportunity to draw conclusions. And sometimes, those conclusions remain frustratingly uncertain. Some researchers accepted the ambiguity, viewing it as inherent to the situation. "We may never know for certain," one prominent astronomer reflected. 3i Atlas will remain one of the great mysteries, a possible first contact that we can neither confirm nor dismiss. Perhaps that's appropriate. Perhaps the universe doesn't provide clear answers to our deepest questions. Perhaps we have to live with uncertainty and continue searching. Others remained convinced that the evidence was sufficient. Future generations will look back and wonder why we hesitated to accept the obvious, predicted one advocate of the artificial origin hypothesis. The mathematical signals, the trajectory control, the structural features, everything pointed to technology. We were visited. We detected the visitor, but we lacked the courage to accept what the data was telling us. If the signals aren't random, someone made them. The cultural legacy of 3i Atlas persisted in subtle but significant ways. Humanity's relationship with the cosmos had shifted. The universe felt less empty, less lonely. Even without definitive proof of alien intelligence, The possibility had become vivid and immediate. We knew that objects from other star systems could arrive in ours. We knew that such objects might exhibit unusual characteristics. We knew that signals might emerge from unexpected sources. The experience changed how we thought about our place in the cosmos. We were no longer children, ignorant of the larger world beyond our home. We were aware that the galaxy is vast, ancient, and potentially populated. Whether 3I Atlas was natural or artificial, its passage reminded us that we inhabit a dynamic universe where surprising things can happen, where mysteries can arrive unannounced, where the impossible might occasionally prove possible. Educational programs incorporated lessons about 3I Atlas into curricula, using the case to teach scientific methodology, critical thinking, and the handling of ambiguous data. Students learned how to analyze evidence, consider multiple hypotheses, weigh probabilities, and live with uncertainty. The case became a teaching tool, demonstrating both the power and the limitations of scientific inquiry. Science fiction authors embraced the mystery, creating countless narratives exploring what 3I Atlas might have been and what its visit might have meant. Some stories imagined it as a benevolent explorer, gathering data to share with distant creators who wanted to understand life throughout the galaxy. Other stories cast it as a warning beacon, marking humanity as dangerous or primitive and advising other civilizations to avoid contact. Still other stories suggested it was one of millions of probes mapping the galaxy, part of a vast network created by ancient civilization whose current status remained unknown. These fictional explorations served a purpose beyond entertainment. They helped humanity process the experience, to imagine possibilities, to prepare psychologically for a cosmos that might contain others like us. Fiction provided space to explore hopes and fears that scientific discussion couldn't fully address. If the signals aren't random, someone made them. The signal analysis continued long after the object's departure. Researchers who had devoted careers to other topics found themselves drawn to the 3I Atlas data, unable to resist the puzzle of those Fibonacci-timed pulses. Every few months, new papers appeared proposing alternative interpretations, additional statistical tests, novel approaches to extracting meaning from the limited data. Some analyses focused on potential secondary signals that might have been missed during initial observations. Perhaps the Fibonacci pattern was just the obvious layer intended to attract attention, while subtler encoding carried actual information. Teams reprocessed archived data, using increasingly sophisticated algorithms, searching for hidden patterns in noise, variations in polarization, subtle frequency modulations that might have gone undetected. Other research explored the possibility of delayed signals transmissions that 3I Atlas might have left behind in some form. Perhaps the object deposited relay stations or beacons during its passage. Perhaps signals were still present somewhere in the solar system, waiting to be discovered. Searches were conducted, though nothing definitive emerged. The obsessive attention to the data reflected both scientific curiosity and human need for closure. The mystery of 3I Atlas had no satisfying resolution. It simply ended, leaving questions unanswered and speculation unconstrained. In the absence of definitive answers, analysis continued indefinitely, each researcher hoping to be the one who finally unlocked the puzzle. If the signals aren't random, someone made them. The philosophical implications were debated in academic circles and popular forums alike. What did the possible existence of extraterrestrial intelligence mean for human self-understanding? If we're not unique, not the only intelligence in the cosmos, how does that change our sense of significance and purpose? Some philosophers argued that contact with alien intelligence would be the most transformative event in human history, forcing complete reevaluation of our place in the universe. Others suggested that the impact would be less dramatic than anticipated. Knowing other intelligences exist doesn't fundamentally change the human condition or the daily realities of life on Earth. The debate touched on questions of meaning and value. Do we matter less if we're one civilization among many? Or do we matter more as participants in a larger cosmic community? Does the existence of older, more advanced civilizations diminish human achievements? Or does our potential for future growth and contribution remain regardless of who else exists? Religious and spiritual traditions engage these questions from their own perspectives. Some saw potential alien contact as consistent with divine creation, arguing that a God capable of creating life on Earth could surely create it elsewhere as well. Others grappled with theological challenges, questioning how various doctrines of salvation, incarnation, or divine relationship might apply to non-human intelligences. The discussions were often speculative and abstract, but they served important purposes. They helped humanity prepare psychologically for possibilities that might become realities. They explored frameworks for understanding experiences that fell outside our historical precedents. They demonstrated that regardless of whether 3I Atlas was natural or artificial, the mere possibility of alien intelligence required serious philosophical engagement. If the signals aren't random, someone made them. The detection systems continued operating, watching the sky with patient vigilance. Astronomers maintained surveys searching for additional interstellar objects. Radio telescopes listened for signals. Data streamed constantly into archives where automated algorithms searched for patterns, anomalies, signs of something unusual. And occasionally, false alarms occurred. Objects that initially appeared to be interstellar visitors were eventually identified as conventional asteroids or comets on unusual orbits. Signals that briefly suggested artificial origin turned out to be interference or natural phenomena. Each false alarm generated brief excitement followed by disappointment, a reminder that the universe is full of ambiguous phenomena that can mislead even careful observers. But the searches continued because the alternative, not looking, not listening, was unacceptable. Humanity had seen enough to know that interstellar visitors could arrive. We had heard enough to know that unexpected signals could emerge from the cosmic void. Whether we would ever encounter something definitively artificial remained uncertain, but we would be watching, ready to recognize it if it appeared. The technical capabilities continued improving. New telescopes with greater sensitivity, better algorithms for distinguishing artificial signals from natural noise, faster response protocols for coordinating observations. Each improvement increased the probability that if another visitor arrived, we would detect it, study it comprehensively, and perhaps finally obtain the definitive evidence that 3I Atlas had tantalizingly suggested but never quite provided. If the signals aren't random, someone made them. The unanswered questions lingered, frustrating in their persistence. What was 3I Atlas? If artificial, who made it? What were they like? Where were they now? Did they know about Earth before sending the probe, or did they discover us? What did the signals mean beyond their mathematical structure? Were they trying to communicate something specific, or simply announcing presence? Did our attempts at response reach the object? If so, what did the creators think of our reply? And perhaps most haunting, are they still watching? Did 3I Atlas transmit its observations back to its creators? Somewhere in the galaxy, light years away, do they now know that Earth exists, that it harbors life, that it has developed technology? Are they discussing us, debating what we mean, considering what to do next? Will they send additional probes? Will they visit themselves? Or was this single passage the only contact we'll ever have? These questions had no answers, only speculation. The distances involved meant that even if 3I Atlas had transmitted data back to its origin, we wouldn't see any response for years or decades or centuries, depending on how far away the source civilization might be. We might be at the beginning of a conversation that would unfold over generations, each exchange separated by years of light-speed propagation delay. Or we might be alone again. The brief visit concluded. The visitor departed. Silence restored. Perhaps 3I Atlas had fulfilled its mission and moved on. Perhaps it would never return, never respond, never provide the definitive answers we sought. Perhaps we would spend the rest of human history debating what it was and what it meant, with evidence forever insufficient to resolve the uncertainty. If the signals aren't random, someone made them. The final data archive contained everything humanity had gathered about 3I Atlas. Thousands of images from hundreds of telescopes, spectroscopic measurements spanning ultraviolet to radio wavelengths, radar profiles mapping surface structure, trajectory calculations documenting every observed position, and, of course, recordings of those mysterious signals, the Fibonacci-timed pulses that had initiated the entire mystery. The archive was made publicly available, preserved in multiple institutions worldwide to ensure it would survive for future generations. Whatever conclusion humanity eventually reached about 3I Atlas, the raw data would remain accessible for reanalysis, reinterpretation, and continued study. Perhaps future scientists with better technology or deeper insight would extract meanings we had missed. Perhaps the archive would become historical curiosity, a reminder of when humanity briefly wondered if it had been visited, or perhaps it would stand as evidence of first contact, the moment when we confirmed we were not alone. The archived signals remain the most compelling and frustrating data. Future researchers would listen to those recordings, analyze those timing patterns, study those frequency characteristics. They would see what we saw: mathematical structure, narrow bandwidth, stable frequency, directed transmission. They would reach their own conclusions about what it meant, and they would ask the same question we asked. If these signals aren't random, if they show mathematical structure, if they appear deliberately generated and transmitted, then who made them? What intelligence shaped those patterns? What civilization sent that probe? What message were they trying to convey? The question would persist, because the evidence, however compelling, never quite achieved definitive proof. There was always room for alternative interpretation, always possibility of natural explanation, always gap between probable and certain. Science demands rigor, and rightly so. But sometimes that rigor leaves questions unresolved, mysteries acknowledged but not solved. If the signals aren't random, someone made them. Maybe it's coincidence. Maybe it's calibration drift. Maybe some exotic natural process we don't yet understand produces precisely timed mathematical signals at the hydrogen line frequency. Maybe interstellar objects can naturally accelerate, warm themselves, generate magnetic fields, and navigate through solar systems while broadcasting Fibonacci sequences that correlate with human attempts at communication. Maybe all of that is possible. Maybe natural explanations exist that we simply haven't discovered yet. Maybe 3I Atlas was just an unusually interesting chunk of rock and ice that happened to do things we didn't expect, but that ultimately came from purely natural processes. Or maybe, for the first time in human history, the universe spoke in sequence. Maybe an intelligence from beyond our world sent a probe to our solar system. Maybe that probe observed our planet, studied our civilization, and announced its presence through signals carefully designed to be recognized as artificial by any technological species. Maybe we detected those signals, analyzed them thoroughly, and recognized them for what they were: a mathematical greeting from the cosmos, a first word in what might someday become a conversation. And maybe NASA, faced with evidence that was compelling but not conclusive, chose caution over announcement. Maybe they decided not to claim discovery without absolute certainty, preferring to describe what was observed while avoiding definitive interpretation. Maybe they believed that extraordinary claims require extraordinary evidence, and that 3 weeks of Fibonacci-timed pulses, however intriguing, didn't quite meet that threshold. Or maybe they knew exactly what 3I Atlas was, exactly what those signals meant, and decided that humanity wasn't ready for the truth. Maybe the full data remains classified, the complete analysis hidden behind security protocols, the definitive conclusions shared only among those with clearance and need to know. Maybe the public statements emphasizing uncertainty and multiple hypotheses were carefully crafted misdirection, acknowledging just enough to maintain credibility while concealing the most significant discovery in human history. We may never know which interpretation is correct. We may never obtain the additional evidence that would resolve the ambiguity. 3 Atlas has departed, receding into the darkness between stars, carrying its secrets with it. The signals have ceased. The mystery persists. But somewhere in the archives, those recordings wait. The Fibonacci pulses, preserved in digital formats that will outlast our current civilization. And anyone who listens will hear what we heard, a pattern that probably, almost certainly, could hardly be anything other than deliberately constructed. If the signals aren't random, someone made them, and NASA knows it.